Here we have a problem in which we need to predict products, and that's another type of problem. Here we see a sequence of reaction. We're starting from benzene. What we need to do in this case is draw the product of each of the reactions. So we don't have substituents yet, so it's just benzene. The first reaction is a nitration. So what I'm going to do here is say reaction number 1 is HNO3, so nitric acid, sulfuric acid. And what this is I am making nitrobenzene. Next, I have another reaction. The next reaction is a chlorination. So number 2, I have chlorine and aluminum trichloride, my Lewis acid. What is this doing? Well, a chlorination, but now I have a substituent. I need to determine where the chlorine is going to enter. So remember here that this is now you have installed a deactivating group, and this is meta directing. So you're going to be directing here, and it is equivalent. So my product for that step 2 here, is the following. So I have nitro, and I have installed the chlorine meta to the nitro group. The next step we see here that is zinc in hydrochloric acid. That is the reduction of the nitro group to the amine, but immediately after, we need to do step 3 and 4 and do sodium hydroxide because to recover the free amine. Let's draw the product and then explain a little bit more. So what is that? So you will reduce this group to the amine. Let me do that, just that step to see why we have the sodium hydroxide. So because you reduce that, but under acidic conditions, you will have this. So the chlorohydrate, in fact. And what you do in step 4 is actually deprotonate. So step 4, you add NaOH as an acid-base reaction to get, finally, metachloroaniline. So again, this is how you draw the product for each of the intermediate reaction. Nitration, once you have the nitro group installed, we know that it's deactivating, so it will be meta-directing. So you have now the chlorine meta to the nitro. Following step is the reduction. And pay attention that because this is acidic conditions, the aniline will be protonated. So you need to do an acid-base reaction to deprotonate and recover the final product.